Let's move on to talk about the authorization solutions part 1. Now, a very important consideration when designing any kind of security system would be to determine how the users will receive their rights and permissions. And the different models governing this are what we refer to as the access control schemes. Now, speaking of the access control schemes, we do have two of them. The first is the discretionary access control, the DAC, and then we also have the role-based access control, the RBAC. Now, on the DAC, this will be based on the primacy of the resource owner, and this basically means that the owner will have complete control over that resource, and then they can decide who to grant the rights to. This obviously makes the system very flexible. Unfortunately, though, it also means that this particular kind of scheme can be very vulnerable to insider threats and abuse of compromised accounts. Now, with RBAC, this will add an extra degree of centralized control to the DAC model, where the users, they're not given rights explicitly or directly, but rather implicitly, which means through being assigned a role. So you can have different roles, like the role of an admin, an editor, an author, a regular user, and all these roles will have their set of privileges. So any user, based on what they need to do, can be assigned any one of those roles. So the RBAC can be partially implemented through the use of security group accounts. Remember we talked about group accounts earlier. Now, for file system permissions, with the file system security, each object in the file system will have an ACL associated with it, an access control list. Now, the access control list will contain a list of accounts allowed to access the resource, and each record in the ACL, keep note of this, is what we call an access control entry, an ACE or ACE. Here's an example. You have the user here being assigned certain permissions like the list folder, read data, read attributes, read extended attributes, and also read permissions. Now, under Linux, users can be given 3 different types of permissions. They can either read, write, or execute. Now, read, represented by R, means they can access and view the file. Write, represented by W, means that they can modify the file. And of course, execute, represented by X, means that they will have the ability to run a script or program or even perform a task on that directory. Now, whenever commands regarding file system permissions are being written, they're usually written in the context of the owner user U first, followed by the privileges or the permissions that the group account will have, represented by G, and finally the permissions granted to all other users, represented by O, will be written. Now take a look at this string right here, D space RWX R-X R-X home. What exactly is going on here? We have the directory D. Now RWX, those will be the permissions for the user or the owner, which means right here the owner can read, can write, and can execute. Remember once again that read represented by R, write represented by W, and of course execute represented by X. And then the next group, that is the group account, the group context, they have R-X. This means that they can read, but they cannot write, but they can execute. And the exact same falls for the other users. They too, they can also read and execute, but they cannot write. Now, the chmod command is used to modify permissions and can be used either in the symbolic or the absolute mode. Take a look at this. The command in the symbolic mode will work as follows. You'll have chmod and then G plus W, 0-X home. What's going on here? Remember that G represents the group account, the group context. So here, because we have plus W, that means we are appending the write permission. We're giving the group users the ability to write. However, the 0-X means we're removing the execute permission from which group? The other users group, represented by O. And by contrast, the command can also be used to replace existing permissions, the chmod command. Look at the very first example that we wrote, the d rwx r-x r-x home. It can be rewritten like this: chmod, the user or the owner of the resource, equals rwx, which means they can read, write, and execute, while the group account equals rx, they can read and execute, and same goes for the other user's account as well. Now, in absolute mode, the permissions are assigned using octal notation, where the read permission will have the value of 4, write permission the value of 2, and of course the execute permission the value of 1. So now we can say chmod, or chmod rather, is 755 home. Again, the very first number here, 7, will represent the total value of permissions for the user, 5 represents for the group, and then the last 5 represents for the other users. So let me ask you a question here. What if the user only had the ability to read and write? What would the value be? The value would be 6, because 4 plus 2 equals 6. And there you go. Very, very, very simple, right? Now, let's talk about the mandatory and attribute-based access control. This is the third scheme. And now, the DAC and RBAC models expose privileged accounts to the threat of compromise, so more restrictive models can be used to mitigate these threats. And here comes the mandatory access control, the MAC. Now, this is based on the idea of security clearance levels, otherwise known as labels, instead of access control lists. So in a hierarchical structure, subjects are only permitted to access objects at either their own clearance level or below. The labeling of objects and subjects takes place using pre-established rules which cannot be changed by any subject account and are therefore non-discretionary. So subjects are not permitted to change their own label in this particular scheme. Now, for the attribute-based access control, the ABAC ABAC, this is by far the most fine-grained type of access control mode, and it is capable of making access decisions based on a combination of subject and object attributes plus any system-wide attributes. The wonderful thing about this model is that it can also monitor the number of events or alerts associated with a user account, or even track resources to ensure they are consistent in terms of timing of requests. You can also have another scheme called the rule-based access control. This is a term that can refer to any sort of access control model where access control policies are determined by system-enforced rules rather than the system users. And now, as such, your RBAC, your ABAC, and your MAC, your MAC, they are all examples of rule-based or non-discretionary access control. We also have the last one, the conditional access. Now, this can monitor an account or device behavior throughout the session, and if certain conditions are met, the account may be suspended or the user might need to re-authenticate. So the user account control, the UAC, and sudo restrictions on privileged accounts are examples of conditional access. We now have the privileged access management, the PAM. Here, a privileged account is one that can make significant configurations to a host, obviously. So what PAM does is that it refers to policies or technical controls to prevent the malicious abuse of privileged accounts and to mitigate risks from weak configuration control over privileges. Thank you for watching. I will see you in the next class.